Lovely.
Okay.
So
Thank you everybody for being with us. Today's speaker is Eirini Thomaidou from University of Sussex. She will present a paper with her co-author Dimitris Mirnakis from the University of Cyprus, as I see. Eirini, the floor is yours. You have again 45 minutes to 1 hour, then a Q&A will follow. Thank you for being with us.
thanks, Dimitri. So today I'm going to present to you our fresh working paper together with...
I will interrupt you right away. If you don't mind, full screen the slides. Sorry again.
Sure. Just give me a second. Come on, where is that? Yeah, okay.
Great, thank you.
Okay, I don't know. Initially, I had put it on full screen. I don't know why it went back. It might be something on my laptop. Anyway, so today I'm going to present you a paper, our fresh working paper together with Dimitris under the title Estimating Product Quality Made Easy. Why do we bothered to write a paper about how we estimate product quality and what does this mean making it easy? Okay, so first let's discuss why product quality is important on international trade. So during the last decades, trade economists have identified product quality as an important determinant of trade at the aggregate level, as well as product quality is found to be shaping trade activity at the firm level. Okay, there is much research. I'm only presenting one paper here by Bernard van Beveren and van der Busche that actually state and show how important the intensive margin is at the firm level. For example, Bloom et al., I think it was 2016, they show that it is the intensive margin of trade that adjusts the most during booms or crises. This makes us look closer at the intensive margin of firms at the firm level. And given that is proved that product quality is an important part of the intensive margin of trade, we have decided to look closer at product quality and how we can infer it. In order to give you a general definition of product quality in our setting is any intrinsic characteristic that improves the consumer appeal of a product given its price. It is product quality. The main challenge is that product quality is something unobserved. It's an unobserved attribute that we as consumers, we are attributing it to a product we're considering to buy. In the related literature in the past, a common proxy for this unobserved attribute quality has been export prices or unit values in cases where we are looking at international trade flows, because international trade data sets do not report prices themselves, but instead unit values. However, export prices do not necessarily suggest high product quality. Export prices may vary for reasons other than product quality. For example, undervalued exchange rate, input quality, innovation in production, and other factors that may inflate export prices are included, of course, there. For example, Chinese skirts might be cheaper than Italian skirts in the US market, possibly related to lower input quality. If we are about to use export prices in order to take into consideration product quality and measure the intensive margin of trade, then we're missing this important feature of the unobserved attribute that the consumer is giving to the product that he is actually buying. An easiest example to understand, this is for Dimitris, is like, okay, we have an exporting firm. We know about this. Imagine Faye exporting yogurts to Germany or to the UK. We do have Faye yogurts here. And English people, at the end of the day, they have started recognizing Faye yogurts as the original Greek yogurt. So the attribute to Faye yogurts, better, higher quality. It's recognizable. In this sense, in this example, product quality is the factor of recognizing a trademark that Faye is, or an exporter. So this exporter is everywhere. It's good. It's tasty. I know that this product is of higher quality. Another thing that higher quality is the perception that this product is made using better milk or Greek milk that is used for this yogurt is actually of higher quality. All these things that create a perception to the consumer about how quality, how it's a product's quality is ranked between in a ladder, let's say, between other products. This is what we call here product quality. So again, it is unobserved, and for this reason, the related literature have used.
Eirini, may I ask a question?
Yes, may I switch off the full screen for a while just to be able to see you? Sorry about this, because I don't know who is picking.
Okay.
No, fine.
Good.
You say quality is unobserved. And it seems contradictory to me to the definition you gave. So do you mean it's unobserved to the econometrician?
Yes, it is
Okay.
unobserved
So
to the
only to the
econometrician.
econometrician.
Exactly. Yes, you're true. That's correct. Sorry about this.
In fact, this answers, in fact, my question about quality being unobservable, because I was always thinking that this is endogenous for the producer. I can choose what, I don't know.
Level of quality.
Yeah, exactly. So I know the milk I use, I know the plastic cup I use or whatever. I know how much money I spend on advertising. So, but now I understand the meaning of unobservable. So thank you, Daphne, for clarifying this. This also helped me. So Eirini, yeah, please feel free to give further clarifications, but this is important, at least for me.
Yes, sure. After all these years discussing about product quality, I'm usually omitting the unobserved about the econometrician. So I should add it to the slides. Lovely. So apart from unique prices, another ad hoc proxy for product quality is expert assessments. Crozet et al. And Chen and Juvenal, I think, use wine expert ratings to proxy for wine quality. Also, Atkin et al. Use expert assessments for rug quality. So this
Eirini,
is
if you
one
don't
way
mind,
to go.
You can go back to full
Oh,
screen.
yes, sorry, yeah.
No problem at all. Thank you.
I'm clicking it. Yeah, okay. Sorry, it's from start. Okay. So
Okay, works fine.
another ad hoc proxy for estimating product quality has been developed a decade ago, let's say 15 years ago, by Halak and Schott. However, at the country level, so Halak and Schott say that among countries with identical export prices, the country with a higher trade balance is revealed to possess higher product quality. This is ringing bells about demand estimation here, okay? And at the same period, however, it got published a bit earlier, Candeval in 2010 releases product level quality estimates on the basis that higher quality is assigned to products with higher market shares conditional on prices. After almost a decade, and following the related literature on international trade that has moved from looking at products and aggregates at the country level to working at the firm level, so the so-called new trade theory with heterogeneous firms initiated by Mark Melich, Piveteau and Smagghue introduce another quality inferring methodology together with a theoretical model to back it up, that is actually a combination of what Halak and Schott had defined as product quality, which is the exact definition I gave you earlier, together with the quality estimation technique at the country product level proposed by Candeval 10 years earlier. So Piveteau and Smagghue in 2019 introduced a SES demand system where quality acts as a utility sifter. In such systems, there is an important assumption. The important assumption is whatever we use to inflate this demand system must be exogenous to the demand shock we're going to look at, okay? So in this methodology, Piveteau and Smagghue assumes that real exchange rate shocks on a firm's inputs in production are cost shocks and they are exogenous to any demand shock that may occur. Of course, this has a lot of issues. I'm going to discuss the two major ones. However, let's first discuss about the endogeneity arising in such a demand estimation. So the main idea on all of this is that, okay, we do have export and import flows. We want to infer product quality at the firm product level. And what we do is we estimate a SES demand system where quality is the utility sifter. So the unobserved error for the econometrician, together with a few other attributes from the demand system, they actually they construct the quality measure that we're going to discuss. Of course, demand systems have endogeneity of prices. In this paper, in this methodology by Piveteau and Smagghue, this endogeneity of prices is addressed by real exchange rates interacted with firm-specific importing shares. So the first thing you might you might point here is that how exchange rate shocks, okay, are not on inputs are not affecting the demand shock itself. And since inputs are important determinant for product quality, what are you talking about, okay? So the instrument here proposed by Piveteau and Smagghue, the real exchange rates interacted with firm-specific market shares, etc., etc. We're going to see about this in the future. The instrument that Piveteau and Smagghue propose is endogenous to quality. To this end, they simply add variety-specific fixed effects, since they claim that higher quality producing firms import higher quality inputs from countries with stronger currencies, and at the same time, they introduce a general measure of product quality at the country level, which is the import share interacted with a country's origin country's GDP per capita, so as to take into consideration improved competitiveness to a specific exporting destination due to importing higher quality inputs from the same country. And they are doing the same with exporting higher quality products to that destination by introducing export shares interacted with GDP per capita of the same country. So they are trying here to help the instrument, the weakness of the instrument, by adding other control variables into the demand estimation. And then they are taking the demand estimation error together with the average import-weighted GDP per capita of the firm exporting to a specific destination, together with these variety-specific fixed effects in order to construct product quality. I know it is difficult to grasp, especially since I'm just talking very quickly about an existent methodology. The key thing to keep here is that it is a very, very complex demand specification consisting of two stages, because on the first stage, since there was an instrument that was weak, what they did was first run the specification at the aggregate level, obtain price estimates from the economy level, and go back using these estimates into a second estimation in order to get the error from there. Very complex, quite unclear, quite confusing. So, and also the key is that this kind of estimation, this methodology requires import data at the firm product destination year level, export data correspondingly, of course, because we're talking about international trade, but also firm level confidential data, such as a firm's operational costs. There is another methodology that instead of this instrument based on real exchange rate shocks, real exchange rate interacted with the firm's operational cost, they use electricity prices and making it even more difficult to find electricity prices at the plant level, firm plant level, in order to construct an appropriate instrument. So to this end, before I move on, let me stress the necessity for a simple methodology, okay, based on the same idea, again, that this unobserved attribute that the consumers are giving to products is coming through a demand estimation, a very detailed one, okay? The main challenge is always price endogeneity. Every paper that I mentioned up to now, they use instruments that they are either obtained at the country level, so they are not appropriate to use at the firm product level, or when they actually use instruments at the firm level, firm product level. These instruments require a lot of data that are not accessible to every researcher, okay? Also, the existing linked instrument employs weak or inappropriate instruments. By inappropriate, I mean firm level analysis using country level instruments, losing a lot of information there, as well as I mentioned earlier, instruments that might be endogenous to quality at the firm level, and then remedy this by, let's say, additional techniques. Also, the data requirements are clearly high, since, for example, Piveteau and Smagghue technique require highly disaggregated trade data sets of both exports and imports matched together at the firm product level, as well as confidential data on firms' details such as operational costs or the electricity prices that the firm has on its contract with the electricity provider. So what we propose here today, we propose a methodology that is still based on a demand estimation, but provides quite a shortcut to avoid the complex demand estimation I've already mentioned. In terms of data requirements, this methodology narrows down the data intensity of quality estimation, okay? Since it only requires either export highly disaggregated data or import highly disaggregated data, depending on whether we want to see the quality, the product quality of Greek importers or the product quality of Greek exporters, okay? So depending on what we want to look at, we use the corresponding Eurostat dataset. Now, this single requirement, single dataset requirement allows for higher number of observations. This is not straightforward if you just think about it, but later on you will see that in our application, because we're going to apply the proposed methodology as well as Piveteau and Smagghue methodology in our data set, you will see that using the three merged data sets drops like a huge number of available observations, just because usually confidential data are coming from firm level surveys of statistical registries. So not all firms are obliged to answer these surveys. And for the Greek case, these surveys are provided by Elstat, and they are stratified samples every year, like random ones, but still stratified to show a proper picture of the size of Greek firms, okay? So avoiding such use, the use of confidential firm level data, we have a higher number of available observations, which actually gives us better asymptotics on whatever we're doing. Also, the methodology we propose overcomes the IV methodology's challenges. Up to this moment, all these papers introduce IV methodologies to the demand estimation. So the methodology we propose overcomes the IV methodology challenges. So we do not need to construct an extremely creative firm level instrument. We do not need to think about in every detail, think about how the instrument at the firm level we're going to introduce, based of course on data availability, is going to be associated with the unobserved error, our quality estimate coming from the demand estimation. Also, we are overcoming another basic challenge of ID methods, the one of weak instruments. If we fail with our creativity to the firm level instrument, we might end up with a weak instrument. So this weak instrument will increase the volatility of the estimator and actually causing various biases. This way, the methodology that we're going to propose today avoids these various biases, like selection biases or simultaneity biases, okay? So what we propose, instead of working with a weak instrument or a very complicated or a data demanding methodology, we propose tackling the price endogeneity challenge by using the properties of the copula distribution. So we estimate a demand estimation, okay, augmenting it by this part of copula transformation here, okay? So you can see we are regressing our quantity at the firm product destination year level on export prices at the firm destination product year level, an entry dummy, which is standard in the related literature about a firm entering a specific destination with a specific product at this specific year or not. So if you are a new exporter of Fage yogurts to China, then you have a value of 1 at this entry dummy, as well as average quality indicators at the country level, because on international trade literature related to product quality in exporting, we do know that we export better quality products, higher quality products to more prosperous countries. So if you have Germany and also you have, I don't know, Albania, you are exporting higher quality yogurt to Germany than the one that you're exporting to Albania. Okay, so and then we have also our high dimensional fixed effects. We have a high dimension in order to actually incorporate in our regression different aspects of trade values that are of use to our quality measures. So we have a firm product destination spell fixed effect, and by spell we mean the combination of firm product destination existence in the past. So given that our exporter is exporting this same product, okay, before than today, we are also introducing, this is very standard in the related literature, all Halak and Schott, Candeval, Piveteau and Smagghue, as well as Fontanier et al. Use such a high dimensional fixed effect for the reasons of identification. And also we're introducing here another standard fixed effect, which is a product destination year fixed effect to take into consideration changes in a specific market for this product in a specific year. And finally, we have our error term here, which, since we're introducing the Gaussian copula, has this very beautiful but complex for me form, okay? So we are introducing in our data this augmented regression, where once again, P star is a copula transformation of our prices, okay? Here I have the definition of it for those who are interested. And what is important for our regression is to have this copula transformation statistically significant at the end of the day in order to be sure that this regression is accurate, working, goes on, goes forth. Now, I'm quite sure that you are confused. A comment that I have here is that if we were about to go back to Piveteau and Smagghue technique, and I'm mentioning this again because I'm going to show you a comparison of our quality measures results with their quality measures results. The specification that was running in their case was a very similar one. Of course, it was a two-stages regression since it included an instrument, okay? The only thing that is missing is the copula part. So I haven't changed anything, just to allow for comparison of the introduction of this simpler demand estimation, a simpler quality measure following a different kind of demand estimation, okay? So going back to the quality measure that
can I ask a question?
Yeah. Sorry, I need to see you. Yeah.
Yes, in the previous slide,
previous slide.
you said that this P star is a copula transformation. Does the copula transformation require two variables?
What do you mean, two variables?
When we do the copula, it's like to create a form of dependence between two variables. That's the definition of the copulas. You want two variables. So why do you call it copula?
Mihaly, I think she means the transformation that you do to the univariate before you apply the copula. That's what.
Yes, that's true. Sorry, I'm not an econometrician, so I'm missing quite.
Yes, but still, the copula is between two variables.
Yeah, but before you apply the copula, you transform the univariate.
Eirini,
So this transformation, she calls the copula transformation.
You need two variables for the copula word. It's two variables. That confuses me.
Dimitri, I think that you want to step in.
Yes, if I can make a clarification here, the copula approach, how does this copula approach? As Professor said earlier, you definitely need two variables because copulas link distributions. Now, the copula approach, what the copula approach does is model the dependence between the endogenous variable, which is the prices in our case, and the error term. This is how it works in this case. So through this assumption that the two variables, the prices and the error term, follow a Gaussian copula in our case, we can calculate the conditional expectation of the error term. In our case, the error term, Eirini, of the previous regression before the augmentation should be epsilon this
Sure.
one that goes inside the variance. This is the error term, the original structural error, which is the one that is correlated with the prices, P, which is in the log, in the above line. So we model their correlation, the dependence, through a Gaussian copula, which allows us to compute the conditional expectation. And in the case of the Gaussian copula, this expectation takes a linear form, which allows this augmentation of the model. This is part of another paper that I am working with Professors Christopoulos and Zavalis, and not it goes beyond the scope of this paper, but just as a clarification so that we can proceed.
Thank you, Dimitri. Thank you. I definitely need to write this down in order to be able to express it correctly next time. Okay, so okay, the quality measure. So following Piveteau and Smagghue theoretical idea, which was based on Candeval into...
If you don't mind, full screen again, thank you.
Sorry, I'm always forgetting, sorry. So we infer, it's not getting on, clicking, but no. So I'm going to try again. We infer quality at the firm destination product and year level using the variation of residuals once price variations have been controlled for. So we stress that quality is defined relatively to the average quality in a destination market. Here you can see an example of clothing accessories exported to Germany in 2014. So you can see the minimum estimated quality for this product exported to Germany and the maximum level as well, and then how other firms are positioning themselves in the quality ladder. So this is the kind of quality measure we're talking about, is a ladder measure of quality where we have firms positioning on it. Now, let's talk a little bit about data requirements. Again, the methodology that we're proposing with Dimitris only requires export or import firm level data. However, here today, I'm going to present the full data sets that I have access to, and we require these data about in order to run the methodology proposed by Piveteau and Smagghue or Fontagnetta, the one with the electricity prices as instruments. So in this analysis, the whole paper, we're going to take advantage of a unique combined data set for Greek exporting firms. This data set is based on firm level data on Greek exports and imports from 2002 to 2014 from the Eurostat's extra EU trade statistics and also Eurostat's intra-EU trade statistics. We are also going to have additional information at the firm level from the annual manufacturing survey conducted by the Hellenic Statistical Authority. I vaguely mentioned this earlier, which is available to me for the years 2002 to 2014 again. This survey, the AMS survey, contains data related to the economic activity of medium and large-scale manufacturing firms, such as the wage bill, the number of their employees, value-added operating costs, which is important for Piveteau and Smagghue. It's really important for Piveteau and Smagghue technique. In our experiments, in our exercises, we're going also to use a firm's employment and a firm's investment details in order to run comparison exercises that exist in Piveteau and Smaggheue's paper to show the robustness and appropriateness of our instrument. So the mapping of all these data sets was based on firm stacks identification numbers, which was first transformed to a random unique identified key set by Elstat. And of course, we also enrich the combined data set with the destination or sources kind size, GDP per capita, I mean, from the World Development Indicators of the World Bank. Yeah, I think I've covered all the sources that we need in order to implement Piveteau and Smagghue instrumentation strategy. So I have also here a table with a cross-country comparison of exporting firms' main statistics available for Belgium, France, Hungary, Sweden, and Portugal from other papers, mainly Baldwin et al. In 2008 and Bastos et al. In 2018, in order just to see that Greek exporters' main statistics are similar to the Portuguese ones, and which is also a small country, European one, and also close to the range of average numbers of export destinations and exported products as well, reported for Belgium, France, Hungary, and Sweden. Here we present estimated price elasticities for 15 different product categories at the firm industry level. The estimated coefficients at the firm level are statistically significant and range from -784 for the industry of footwear and headwear to -1.010 for transportation. On the first column also, we report simple OLS estimates on the demand estimation, just for completeness. And you can see here the number of observations included for every single industry. And I'm stressing this out because on the next table, we're going to see the same estimation, but following the same exercise, but this time not following our proposed methodology, but instead following Piveteau and Smagghue one. So I will be moving forward to show you the table with the corresponding estimation using Piveteau and Smagghue technique implementation methodology. The estimates here vary between -150 for the industry of chemicals and allied to -2.89. Now, findings in the related literature vary considerably depending on the data sources and the estimation methodologies used. Piveteau and Smagghue report a range on their own paper, okay? They report a range of -3 to -4.4, while Fontanier et al. With the electricity prices instrument, they find an export price elasticity of around -5. There are other papers estimating even higher elasticities and other papers that are using tariff data to tackle price endogeneity. They report very small demand elasticities of -0.4. It is important to mention that there is another paper that actually applies the Gaussian Copula methodology, the paper by Park and Gupta. They also apply this technique on a demand estimation, on a standard demand estimation for retail prices, if I remember correct. and they find coefficients very close to the ones that we find here of minus 0.88, I think, maybe 89, and 0.90 something. Finally, to mention that according to Piveteau and Smagghue, industries relying on homogeneous inputs such as the mineral products, which is here, the stone and glass here, they have F statistics close to 0 in their estimation, which generates very noisy estimates of their price elasticity. This is something that they point out in their own paper. If you look here at the application on our Greek exporters data set, okay, you can see that there even the value of the coefficient is not extremely varying. It's between minus 1 point something to minus 2 something, if I can see it correctly here, or maybe a bit lower. You can clearly see that the estimates are not statistically significant, okay? Which implies that there is a problem here, okay? And we can definitely spot the problem on the number of observations in each industry due to using confidential firm level data and reducing the size of the sample, okay? Of course, I need to mention that this instrumental estimation here has a single first stage across all industries. This is what Piveteau and Smagghue are implementing in order to tackle the fact that the instrument they are proposing is still weak. So I've done exactly the same thing. Now, if you look back to the estimates we are getting for Greek exporters using the Copula transformation methodology, we have high statistical significance, and if I had added an R squared here, that it would be more than 80%. Not R squared, sorry, it's not the correct, I think Dimitris is the adjusted one. Anyway, this was a striking difference between the two methodologies applied on the same sample. Now, of course, out of these two demand estimations, I have constructed the corresponding quality measures, and then I have run robustness exercises on them. First of all, the quality estimates coming from our proposed methodology were first screened to the ones proposed by Piveteau and Smagghue, both the ones estimated, quality measures, then it is constructed, the correct verb. The ones constructed using Greek exporters data, but Piveteau and Smagghue's inferring technique, and also the original Piveteau and Smagghue quality measures for the corresponding industries, we see that there is a positive correlation, which is a great first step. I haven't presented this slide here, this table here, but I thought it would be good to mention it at the end of the day. And here I first present correlation of both the quality measures with firms' characteristics in order to further validate the quality measure estimated using our proposed methodology in comparison with the Piveteau and Smagghue one. Now, given that this data set, the one used in order to include employment and the firm's capital, uses data from the AMIS data set, we have to reduce our sample, okay? Because the data set does not cover the whole universe of Greek exporters. As depicted in this table, our quality measure presents similar correlation patterns here. Similar correlation patterns to the ones by Piveteau and Smagghue. Different columns include different control variables and also specifications 1 and 2 have a non-reported constant, as well as 3 and 4 correspond, they introduce also destination product and year fixed effects, while 5 and 6 destination product times year fixed effects. This is in order to follow exactly similar exercises in the related literature in order to make this.
You may ask a question here.
Yes, of course.
You say you're using the average wage. So because I know this data, there's no information on the skill level. So this is just an average wage. You don't know the skill
Sorry, at which
composition.
level? I didn't grasp it. In which
You
level?
get you are using the average wage. So you have no, you're using no information on the skill level in the company.
Yes.
Isn't
No,
that
it's
additional?
an average skilled and unskilled. The average wage reported by AMS at the firm level.
Yes, yes, yes. So you are not
It's not firm
controlling for
product.
the skill composition of
Yeah.
employment in the firm.
Yeah, it's not firm product, yeah. Which is exactly the same for all databases used in similar
Yes, but this is a problem with this data.
Yeah.
Yeah.
But yeah, I know, but this is a reason why I'm not actually presenting this in order to show a relationship, but instead to show that both measures, both methodologies give similar correlations with these firm characteristics. It's just an exercise.
Yeah, I understand, and I understand the limitations, and this is what we can do. But given that what we are interested in is the quality of the inputs, the skill level of the workforce is a major attribute of its quality. So I'm wondering whether this is a shortcoming in general. I mean, I can propose a way, maybe I can't. If you had data which had the distribution of the skill level of employment, that would be a better fit, in my view.
Would you mind to send me, if you have a paper on this, to send it to me in order to study it? That would be great.
Okay, yeah.
Thank you.
You're welcome.
Next, I present another exercise. So as product quality is unobserved and suitable quality measures are not widely available, economists in the past were led once again to use prices as a proxy that indicates product quality. I can see the time passing, that's why I'm going to speed up, sorry. However, prices may conflate many factors that are not related to product quality. Also, they're ignoring characteristics that enter the consumer's valuation of the problem of the product. Okay, these are both problems attributed to using prices as a proxy for product quality. To examine this hypothesis, we regress export prices at the firm product destination year level on our quality measure and the length of each market's quality ladder in detail to avoid the presence of an effect on the slope between prices and quality. Due to the dispersion of qualities, prices and quality are normalized in this case, okay, such that within markets, they are centered around 0 and have a standard deviation of 1, okay? It is important to remember that the quality measure we use defines a position over the product's category quality ladder in a specific destination market, not absolute measure of product quality, okay? So here, all regressions include destination product year fixed effects, so as the relationship between price and quality is identified within a market in order not to compare apples and oranges. We have made all these transformations. Finally, we also present results for the same exercise using Piveteau and Smagghue instrumentation methodology as before. So the upper panel is our proposed methodology. The lower panel is Piveteau and Smaggheu's proposed methodology. This way, we want to ensure the consistency of our findings when applied to the data set of Greek exporters, okay? So as shown in this table, there is a positive relationship between prices and the estimated qualities. This is consistent with the quality equals price assumption frequently made in the related literature. However, this correlation weakens as the ladder length increases, implying that prices may be imperfect proxies for quality in long quality markets. This you can see in column 1. However, when considering firms, and now I'm looking at column 2, when considering firms over time by including firm product year fixed effects, we find that firms that change their prices over time, they also change their product quality in the same direction. Additionally, looking at columns 3 and 4, once we look at the sample of destination countries where more than 5 Greek firms export to, the correlation between prices and the length of the estimated quality ladders is positive. This implies that for firms that export their varieties to more than 5 markets, prices can still be a good proxy for quality. However, this does not hold when we look at columns 5 and 6, the sample of firms that export to more than 20 destination countries. Also holding when considering firms over time. In short, our findings suggest that high export prices do not always suggest high product quality. Also, comparing the panel, the upper and the lower panel, we can see that Piveteau and Smaggheu's instrumentation methodology does not incorporate such a finding. Next, sorry, it was 15, okay. Next, we look at quality prices, and this is the last table I'm going to show you. And then I'm going to conclude. So here we look at quality, prices, and the firm's extensive margins. We anticipate observing a positive association between product quality and either the number of destinations or the products exported, both number of destinations and products exported. However, this association is not definitive when regressing export prices on the extensive margins, as prices tend to be positively correlated with export performance in developing countries, okay? Such a positive correlation is not established in developed countries. To examine this, we regress the quality measure and price of a product on the number of destinations or varieties a firm is exporting, and we include market fixed effects to identify the relationship within a specific market, and we also introduce firm destination product fixed effects to address potential endogenous sorting arising from shifts in average quality resulting from changes in the number of destinations or products. Again, we present results both using our proposed estimation methodology in the upper panel and Piveteau and Smagghue instrumentation methodology in the lower panel to provide the benchmark for the behavior of our Greek exporter sample. In the table here, we observed the expected positive relationship between quality and export performance in column 1. However, when examining product prices, no significant relationship to the number of export destinations is observed, while a positive, albeit weak relationship is found when considering the number of products exported by each firm. These findings further verify that prices are not a good proxy for product quality, so we still need a quality measure, okay? And you can see that S&P instrumentation gives also similar results. So in every exercise that we have run, we confirm that prices are imperfect proxies for product quality. There is an imperfect relationship between prices and quality, as prices and quality correlation varies depending on the degree of vertical differentiation present in each market. Price and quality imperfect relationship is further indicated when we're looking at the relationship between quality, prices, and the firm's export performance. Finally, the correlation between the quality measure and firm's main characteristics indicates its utility in capturing heterogeneity across firms related to product quality differences and vertical differentiation. To conclude, this comprehensive analysis provides valuable insights into the nuanced determinants of product quality and its implications for export performance, while also emphasizes the relevance and robustness, which is very important, both of them, of the estimation methodology we proposed to infer product quality among Greek exporting firms. Since this is the first time I'm presenting this paper, I had presented in the past one time the idea of this project at a conference. I would truly appreciate any ideas about robustness, further robustness exercises, or any comments. Thank you.
Thank you, Eirini.